These basic definitions only apply to right-angled triangles. I want to extend the definition for any sized angle. The first step is to let the hypotenuse be 1, so that sine t is equal to y over 1, which equals y, and cos t equals x over 1, or just x. Tan, of course, is just y over x as before. Now these are the new definitions. Sine t is defined to be the y-coordinate of p, that is the red coordinate. Similarly, cos t is the x-coordinate of p, the blue coordinate. At the moment, this angle is 30 degrees, as shown in this little box here. Now, sine 30 degrees is the red coordinate, and cos 30 degrees is this blue coordinate, and both are positive coordinates. If I decrease the angle, you see that the red sine approaches 0 as the angle approaches 0. So sine 0 is 0, but cos 0 is now a coordinate 1. Now let's increase the angle towards 90 degrees. Now we can see that the x-coordinate is decreasing. And when we get to 90 degrees, we see that the sine of 90 is the red coordinate, which is 1, and the blue coordinate is the cos of 90, which is 0. Now we can have angles greater than 90 degrees, like this. Now that one is 120 degrees, and it is the angle from here to here in an anti-clockwise direction. And as we can see, the sine, the red sine, is a positive coordinate, and the blue cosine is a negative coordinate. Cos 120 is in fact negative 0.5. Let's increase towards 180 degrees. Now when we get to 180 degrees, we can see that sine 180 degrees is 0, and cos 180 degrees is the x-coordinate, which is negative 1. Let's increase further. To an angle round about here, which is, this one is 225 degrees from here rotated down to there. And we can see that cosine, the blue cosine, is a negative x value, and the red sine is a negative y value. They're both negative. Carrying on increasing the angle to 270 degrees, we see that the cosine is approaching 0. So cos 270 degrees is 0. Sine 270 degrees is the coordinate negative 1. Further increasing this, we find this sort of position, say here, 330 degrees, sine 330 degrees, which is the angle round there. Sine is negative a half there, and cos 330 is this positive x coordinate. If we carry on and approach 360 degrees, we find that sine approaches 0 again, and this is the same condition as 0 degrees. Starting from 0 degrees again, if I move in the anti-clockwise direction, these are positive angles. This is positive 30 degrees. If I rotate in the clockwise direction, this is called a negative angle, negative 30 degrees. So we can increase this to this distance, which is negative 90 degrees, but it's also the same as positive 270 degrees. Once we understand where sines and cosines are positive and negative, then we can really understand how to draw the graphs of y equals sine x and y equals cos x.